Today we're going to start looking a little bit more at congruence, and specifically congruent triangles. There is an acronym that you're definitely going to want to commit to memory, and the nice thing about this acronym is if you went to any other geometry class in the United States, they're going to have the exact same acronym. A lot of times I don't focus too much on theorems and knowing their numbers or stuff like that, because if you go to a different school, the numbers are going to be completely different because the book's different. Okay? The theorems themselves will be the same, but the number of that theorem will be a little different. But this acronym will be the same no matter where you go. Okay? CPCTC. Okay? And it stands for, obviously, corresponding parts of congruent triangles are congruent. Well, let's see if you agree with that. If I tell you that that triangle and that triangle are congruent, you agree that means they have to have the same shape and the sides have to be the same and the angles have to be the same. So I could tell you that that angle is congruent to that one. Do you think that's corresponding, like in the same spot? Yeah. How about that one congruent to that one? This one congruent to that one. Okay. So if I tell you those two triangles are congruent, do you agree that the corresponding pieces have to also be congruent? Okay. So in other words, that one and that one have to be the same. This one and that one and that one and that one. Okay. So it is believable, but again, mathematicians aren't going to write that every time. They're not going to write corresponding parts of congruent triangles are congruent because it's way too much to write. So we've come up with an acronym, CPCTC. Okay. And you give that to any geometry teacher and they're going to know exactly what that stands for. Okay. As we go through this, proving triangles congruent and showing that they're congruent, we're going to need three very important properties. Reflexive property basically says that the measure of angle 1 will be equal to the measure of angle 1. So in other words, that angle right there is congruent to itself. Do you agree with that? Yes. I sure hope so, or we have some huge problems. Right? That's why it's called the reflexive property, because when you think of a reflection or something that reflects, it's a mirror image of itself, correct? And so that's where that comes from. Symmetric property. It's saying that if 1 and 2 are equal, so maybe this is angle 1 and that's angle 2, right? They're saying if those two are equal, then 2 is equal to 1. If 1 is equal to 2, 2 is equal to 1. Does that make sense? Well, I sure hope so, right? One it goes both ways, in other words. That's obviously symmetric, comes from symmetry. Transitive property is a big one and easily forgotten. And let's just draw another triangle. That might help you. And then I will use some of you as examples. Basically what it says, if I know angles, we'll do it color-coded. Angles 1 and 2 are equal, right? And I know 2 and 3 are equal. What else can you tell me? Basically that, yes. Don't 1 and 3 also have to be equal? I mean, if that's the way it goes. So one example, and we need 3 people, so it's just a huge coincidence over here that we have 3 people. And we won't use names, but everybody here will find this funny. But the people in the recording won't necessarily get much help from this, but that's okay. Let's see that this individual right here, who will not be named, is smarter than this individual right here that will not be named. Okay, you with me? And this individual is smarter than this individual. What can you tell me about the other two? What can you tell me about first individual and third individual? The first individual must be smarter than the third, agreed? Right? Did I really say that? But isn't it something you can figure out? Or you could even do height. You know, if this one's taller than that one and that one's taller than that one, obviously the first one's taller than the last one. Same idea here, but we're going to kind of talk about it in angles. All right? So if this angle is the same as that one and that one is the same as that one, we know the other ones are the same. Okay? So that's transitive property. Okay? Any questions on that? Now, up until this particular section, I kept saying, oh, you could have segment LM or ML, it doesn't matter, right? Well, once you start talking congruence, it does matter. And you have to do it so that basically the symbols match up. Do you see 2 triangles in the picture? Okay. Now, does it seem that the corresponding parts are actually marked congruent? For example, does it look like angle B and angle D are congruent to you? Based on the symbols, they must be, right? How about segment CA is the same as CE, correct? Now, you notice I said that in maybe a different way than you thought I was going to. I said CA is congruent to CE, correct? That's how I said it. Is it okay to say CA is congruent to EC? Unfortunately, it's not. You gotta follow the markings, okay? So if we're gonna do a congruence statement, all they're asking for you is to say which triangle is congruent to which one, but you have to be very careful. So let's just do this top one here. We'll do this top one first, and I think most people like to do it alphabetical, correct? Do you have to? No. The first one is nice. It's your choice. The second one, though, you have to follow the symbols. So in other words, A matches up with what in the other triangle? Why does it match up with E? Because it has one mark, and this one has one mark. Do you see that? So A matches up with E. So B, see how I'm going in the same order. B matches up with B and D. Yeah, we said that one already, right? Because they have two marks, right? B and D. Well, kind of by default, we only have one left, right? But does it still match up? C matches up with, well, so wait a minute. C matches up with itself. What property is that? Kind of reflexive property. Or do you, how come I don't have markings there is another good question. How come I don't have any extra, how come I don't have three little curves and three little curves? Is that okay that I don't have it? Yes. It's the same angle. How do we know it's the same angle? They are. I heard somebody say it. Vertical. So if they're vertical, we don't have to state it, but is it okay to put that in without knowing any information? Yeah, they're vertical. We know that. We didn't have to do that. So what if I asked you for, now the easiest way to do this, let's say I asked you just to state one of them. There is one very specific answer to this question, and I need it in order. If you don't give it to me in order, I will have to mark it wrong. You might know where it is, but you said it wrong. Okay, yes? So I said BC, and she said DC. That is correct. Now, there's two ways you can look at it. If you're given this here, if you already know this, you see here's BC right here, right? It's congruent to BC, right? See how they're in the same spot? Or you can look at it. It goes from two markings, BC does, right, to three, right? And if I go from D to C, do I also go from two markings to three? I do. So is that acceptable? Yes, it is. Is CD acceptable? No. It unfortunately is not, because you're talking congruence. If I just ask you for any old segment up there, is it then okay to say which either way? Yeah, you could say, oh, it's segment AB or BA. I'm just asking you for a segment. I'm not asking you to give me a congruence statement. So this little symbol has just come to be very important. You have to match things up perfectly if you're talking congruence. Okay? Any questions on that statement that I'm making? Well, it's pretty nice when they give you the picture, right? Well, what if I don't? Then draw one. Now, do you have to make these perfect? You have to sit there with a ruler and make sure that, well, I mean, you can if you want, but just go ahead and do something like this. All right, here's A, B, C, right? Is congruent to, I would draw them the same if I were you. So if I had A on the top, what should I put on the top of the other one if I'm trying to make them the same? Based on this, right? If I had A, I better put B, right? And B better match up with E, right? And C better match up with F, right? So once you do that, you can go ahead and start putting the congruent symbols in if you want. We know A and D have to be the same. Is it possible that B and A are the same? Is that possible? But do we know? No, we don't, so we better be safe and put that in there, right? Again, it's possible C could be the same as one of these two, but we really don't know, so we better put 3 in there. Okay. And then we know that AB over here is going to match DE over there, 2 there, 2 there, 3 there, 3 there. So do you basically, I was given information, and have I even read anything yet? No. All I did is I looked right there, and I said, well, you know what? If I'm going to be talking some congruence here, maybe I should get a picture in there so I can find out what's going on. All right? And then let's fill in the information. Have I given you enough time to draw a picture for those of you that want to? All right. AB is 15. There it is. BC, where's that? Down here, 20. AC is 25. FE down here is 3x minus 7. find the value of x, or determine the value of x. Do we have enough information? In fact, we have more than we need, right? We have extra. Okay, so now we have to sit here and figure out, well, how do we do this? Yes. Do we know that 3x minus 7 has to equal 20 in this problem? Yeah, because you see that these congruent markings over here has 3 congruent marks over here, right? And this has the same thing, so we know this better equal 20 as well. And whenever you get algebra and some numbers in the same spots, you can say, well, they better be the same. So I know that one better. So it doesn't equal 25. It doesn't equal 15 because those congruent marks don't match up. Okay? And so we're going to probably add the 7 as your best strategy here. And divide by 3. So x is 9. Did it ask for anything else here? No. Because let's face it, had I asked you for the length of EF, would you have had to have done all this work? Well, now you think I might be tricky and do something like that. That's very possible. Because let's face it, if they ask for the length of EF, just tell me it's got to be 20. Right? Do you have to do the algebra to figure that out? No. All right. But we did figure out the x value, and let's check. If I put 9 in there, does this actually end up being 20? 9 times 3 is 27. It is actually 20. So I'm thinking we probably did that right. Okay. And is there another slide, apparently? And blank. All right. Any other questions on this? All right, so those that are listening to the recording, we are now going to an overhead, which you'll have to get the notes from somebody else.